Okay, so today we're going to talk about absolute value equations. This is a big section in Chapter 1. There's going to be quite a few of these on your SLO test. So this is a big topic for Algebra 2. So we're going to talk about absolute value equations today. We're going to do some examples. We're probably going to be working on this topic for 2 weeks. So you're going to have a little bit of homework to do this week with the lesson, and then next week you'll have a little bit more homework to do as well. So the thing about absolute value equations is you've really got to pay attention to the step sheet, and I did attach that on Google Classroom. And then anytime you have questions or if you feel confused at all, you've got to come talk to me because I'm not going to know otherwise. Okay, so there's the goal. I'm going to skip over this slide because in the grand scheme of things, it's not super important. I just want to kind of talk about the steps and then get to the examples so that this video isn't too long. Okay, so this you should have in front of you. There's a step sheet attached on Google Classroom as well. So if you don't have that out in front of you, you don't have a printer or something like that, that's fine, but you do need to copy this slide down because all of this information is very important. So with absolute value equations, you know that with absolute value, it's the distance a number is from 0 on the number line. So whether the number starts out negative or positive, the absolute value is going to always be positive. So with absolute value equations, we've got two different cases that we have to solve every time. So this here is my original equation. It's going to look something like that. You've got multiple terms inside of absolute value bars equal to something else on the other side. Then we have two different cases. We have case 1, which looks the exact same as the original problem. And then we've got case 2, where it has this negative sign over here on the right. So for case 2, change signs of terms on right side. So every time, no matter what, when you're doing the second case for absolute value equations, you've got to change the sign of the term on the right. So sometimes it might be multiple terms over there. You've got to change both of them. Sometimes it might just be one number. But the most important thing is that you change those signs just for case 2. And then sometimes when we're doing these, you're going to get something called a phony solution. So you did all the math right, everything checked out in that, but when you plugged it back into the original problem, something didn't work out. And you're going to see an example of that and see some examples of that in your homework as well. And we'll talk about that a little bit more in a little bit. Okay, so these are the steps to solve absolute value equations. These steps are foolproof. If you follow them and you follow them to a T, you'll be successful at solving these equations. But if you get stuck along the way or you don't understand something, you've got to ask for help. Okay, so step 1 says to isolate the absolute value. So in other words, the absolute value bars and what's inside them can be the only thing on the left-hand side. So if there's things on the outside of them, they have to be moved over first before you can start solving. So that's what step 1 means. Step 2, it says set up case 1 and 2. So just like we talked about on the previous side, case 1 should look the exact same as the original. Case 2, you should change the signs of the things on the right-hand side. So that's the setup. Step 3 is to solve each case. So we've got to solve the cases separately. We should get two different solutions. Step 4, this is a little bit different. So this is our check step. There's two different parts to this step. So step 1, if there are only variables on the left-hand side, so on the right-hand side you've got no letters, that means you don't have to do the check step. Part 2 of this, if there are variables on both sides, so you have a letter on the left, you have a letter on the right, then that means you have to do the check step to see if both solutions are true or not. And almost always, one of them won't be true. And then if an answer isn't true, you're going to cross that one out. That means it's an extraneous solution. And if it is true, then you're going to circle it as your final answer. Okay, so that was a lot of information, but now we need to just jump in and do some examples. So the question says, what's the solution of absolute value of 2x minus 1 equals 5? So this is my solution, or my equation here. That's what I need to solve. So step 1 on your step sheet says to isolate the absolute value bars. Make sure they're on the side of the equal sign by themselves. Okay, is there anything outside of them? No. So that means we're ready to set up our cases. So case 1 looks the exact same as the original problem. So it's going to be 2x minus 1 equals 5. Okay, and then case 2. Well, case 2, the left-hand side, nothing changes. It stays 2x minus 1. But the right-hand side, instead of having positive 5, I need to change it to be negative 5. And you'll notice how in the two cases I took the absolute value bars away. That's because you really can't solve with the absolute value bars there. So we have to take them away for a minute to be able to solve for x. Okay, and then the next step just says to solve the two cases. So I'm going to start with case 1. I've got 2x minus 1 equals 5. So I need to start and I need to add 1 to both sides. 5 plus 1 is 6. And then I need to divide by 2 on both sides. So x equals 3. Okay, case 2. Again, same first step. I'm going to add 1 to both sides. In your calculator, if you put negative 5 plus 1, the solution would be negative 4. And then I need to divide by 2 on both sides. Negative 4 divided by 2 is negative 2. Okay, the next thing we need to decide is, do we need to do a check step? So remember, there was two different parts to that. If there's no variables on the right-hand side, you do not have to do the check step. So 5 is by itself. There's no letters on the right. So that means I don't need to do a check step, which means these are both solutions to the equation. Again, I didn't do a check step because there was no variables on the right-hand side. Okay, so the next example, it says, what's the solution of absolute value of 3x plus 2 equals negative 3? Absolute value of 3x plus 2 equals negative 3. So here's the thing with this problem. This has absolute value bars on the left set equal to a negative number. So we know that absolute value, whenever you plug things into the absolute value bars, everything that comes out is always going to be positive because it's measuring distance. And distance is never negative. So whenever you have absolute value bars set equal to a negative number that's by itself, you can go ahead and say that it's no solution. There's no solving that needs to be done. If the absolute value bars are equal to a negative number and it's all by itself, then you can automatically say that it's no solution. There's nothing we can do to solve this to make it true. Okay, next one. We have 3 times the absolute value of x plus 2 minus 1 equals 8. 3 times the absolute value of x plus 2 minus 1 equals 8. So, first thing we have to look for is make sure the absolute value bars are by themselves on the left-hand side. This one definitely is not because I've got a 3 outside and I have a minus 1. So I need to move those over in order to be able to solve this. So what I need to do first is get rid of subtraction. So I'm going to add 1 to both sides. 8 plus 1 is 9. Okay, now I need to figure out how to get rid of the 3. So a lot of times students want to distribute that 3 into the absolute value bars, but you cannot do that. You can't distribute into absolute value. So I need to think about how they're attached. The 3 and the absolute value bars are attached by multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 3. So I'm left with x plus 2 equals 9 divided by 3 is 3. Okay. So now we're left with absolute value bars equal a number. So this is what I'm going to base my two cases off of. I can set up my two cases now. So case 1 is x plus 2 equals 3. Remember, I take the absolute value bars away in the cases so that I can actually solve them. Case 2 is x plus 2. Don't change anything on the left-hand side, and I need to change the sign of the 3, so it needs to become negative 3. Okay, now I've got my two cases set up I need to actually solve. So the first one, I'm going to subtract 2 from both sides. 3 minus 2 is 1. For case 2, I'm going to subtract 2 from both sides. Negative 3 minus 2 is negative 5. Now I need to decide if I need to do a check step or not. So do I have any variables on the right-hand side of the equation? No. All I have is a 3. So that means I don't need to do a check step, and these two are both solutions to this absolute value equation. Okay, last example. I've got absolute value of 3x plus 2 equals 4x plus 5. Absolute value of 3x plus 2 equals 4x plus 5. So we have to look to see if the absolute value bars are by themselves. There's nothing outside of them on the same side, so I'm ready to set up my two cases. So case 1 looks the same as the original, so 3x plus 2 equals 4x plus 5. Okay, and then case 2, I don't change anything on the left-hand side, but on the right, I need to change the sign. So 4x becomes negative and 5 becomes negative. So both of those two terms, their signs changed. Now I need to solve. So for case 1, I'm going to get my x's together first. So I'm going to subtract 3x from both sides. 4 minus 3x is x. And now I need to get x by itself, so I need to subtract 5 from both sides. 2 minus 5 is negative 3. Okay, case 2, I have 3x plus 2 equals negative 4x minus 5. So I'm going to start and I'm going to move this negative 4x over. So I'm going to add 4x to both sides. So 7x plus 2 equals negative 5. Okay, I need to work on getting the x by itself, so I need to subtract 2 from both sides. Negative 5 minus 2 is negative 7. And then I need to divide by 7 on both sides. X equals negative 1. Now I need to think about a check step. Do I have any variables on the right-hand side, which means I then need to have a check step? And the answer is yes. I have a variable on the right, and that's an x. So I need to do my check step. So I'm going to do that right under the cases. So with the check step, it has to be in the original problem. So that means the absolute value bars are there, and everything looks the same as the original. So I've got absolute value bar 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. So everywhere there was an x, I plugged in negative 3 and I put in my absolute value bars. Now I just need to solve that and see if the two sides of the equal sign are the same. So 3 times negative 3 is negative 9. Over on the right, 4 times negative 3 is negative 12 plus 5. Okay, on the left, negative 9 plus 2 is negative 7. Negative 12 plus 5 is negative 7. Now I need to do the absolute value of negative 7 is 7. So I've got 7 equals negative 7. Is that true? No. So this is not a solution, and I need to cross that one out. Okay, now I need to do the check step for case 2. So again, this is going in the original problem. So I've got absolute value 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. So notice I did not use the negative signs on the right-hand side like in case 2. I went back to the original problem. Okay, 3 times negative 1 is negative 3 plus 2 equals 4 times negative 1 is negative 4. Bring down plus 5. Okay, inside the bars, negative 3 times 2 is negative 1. On the right, negative 4 plus 5 is 1. And the absolute value of negative 1 is 1. Does 1 equal 1? Yes. So that means x equals negative 1 would be the solution to this absolute value equation. Okay, so here are your homework problems. You're going to have more homework to do as well. You have to ask for help if you don't understand this, because I'm not going to know how to help you if you don't ask for help. So make sure that you reach out if you are confused.